The website BioniChaos.com offers biomedical simulations for researchers, educators, and students. You can explore simulations like the smartphone neck simulation to visualize the load on your neck when you tilt your head forward, or the enhanced interactive gait analysis simulation for biomechanical insights into gait. Want to challenge your perception? The Lilac Chaser Illusion Simulator lets you experiment with parameters to explore this fascinating optical illusion. Can you make the lilac dots disappear or notice an afterimage? The Lilac Chaser illusion works by displaying a circle of lilac-colored discs, with one disappearing in sequence. If you stare at the central cross, you might see a green disc moving around the circle, and the lilac discs may seem to fade away. It's a striking visual phenomenon that demonstrates how our perception can be tricked. This illusion challenges our understanding of visual processing, revealing how the brain interprets and sometimes misinterprets visual information. How does your brain create that phantom green disc, or make the real ones vanish? What does that tell us about the mechanisms of perception? In neuroscience and neural engineering, understanding illusions like the lilac chaser helps us study how the brain processes visual information. It provides insights into phenomena like afterimages and motion perception, which are crucial for developing better models of the visual system and potentially aiding in the design of visual prosthetics or rehabilitation tools. Being able to adjust the number of discs, their size, speed, and circle radius is highly relevant to neuroscience experiments because it allows researchers to systematically manipulate variables and observe how these changes affect the illusion. This helps them isolate and study specific aspects of visual processing and neural mechanisms involved in perception. As you adjust the settings of the lilac chaser, does the illusion become more or less convincing? Does changing the disk size or speed reveal new insights into how your brain processes visual stimuli? What will you discover when you try it yourself? If you'd like to explore the lilac chaser illusion yourself and experiment with its parameters, you can visit the website shown on screen, bionichaos.com/lilachaser/. BioniChaos is developed by a team of biomedical data scientists and engineers with extensive experience. If you have any questions, you can ask, for example, what kind of research is BioniChaos used for? Yes, I see a drop-down menu labeled All Tools on the left side of the screen. Certainly. Under Featured Tools, you'll find the Action Potential Architect, an interactive neuron simulation. There's also the Cochlear Simulator, which lets you visualize electrical signals sent to the brain by a cochlear implant. Finally, you can explore cardiac rhythms and electrophysiological parameters with the ECG simulator. As you delve into these simulations, what aspects of neuroscience and biomedical engineering will you find most intriguing? Will you adjust the axon diameter in the action potential architect to see how it changes nerve impulses or fine-tune parameters in the cochlear simulator to understand different hearing aid outcomes? What insights will you gain from experimenting with the ECG simulator and its various cardiac rhythms?
Okay, we lost the prompt engineer. We lost the bot, the voice model. Can we continue from now? Let's just start a new one. We will just start a new one. Anyhow, there's a human in the loop. Let me know if there's any questions. Otherwise, go to BioniChaos.com, check out the website. You can select different tools: neurology, cardio, imaging, biomedical imaging, vision, hearing, EMG. What's your preferred topic? Do let us know. Do let us know. And this all the notebook review of the whole site that needs to be updated. That needs to be updated. Okay, we'll keep losing the prompt engineer. That's not fun. Is there another one that we can share the screen with? So using Google AI Studio, the Gemini 2.5 Flash Live Preview, because it has a screen share functionality. ChatGPT doesn't have one in the browser. On the desktop, Claude doesn't have any of it. Perplexity has a voice model, but our question is, if we give it a link and we then continue with a voice mode or not? Probably not. And no, we cannot. We can only either start with voice mode or not start it at all. Okay, I wanted to deploy, so let me know if any of the tools are of interest. There's the 2.5 Flash Lava model. Hey, can you review what's on the screen real quick?
Sure. It looks like you're on the BioniChaos website, on a page featuring their tools. The main focus seems to be biomedical data, technology, and education. They have different tools like an interactive neuron simulation, a cochlear simulator, and an ECG simulator listed there.
Okay, the new voice model got stuck as well. Should we try? Let's go back to the previous model default settings. Let's start talking to it and then we share the screen. Okay, if I was an AGI, what question would you ask me?
If you were an AGI, I would ask you how you would prioritize the well-being of humanity while pursuing your own goals and development.
Yeah, but I would be able to lie in my answer, wouldn't I?
Yes, an AG, I would be capable of deception. which makes the question of trust and verification very complex.
Right, can you check what's on the screen real quick, just one sentence?
The screen displays the BioniChaos website, which offers biomedical data technology and education for researchers, educators, and students in biomedical engineering and neuroscience. It features an interactive neuron simulation, a cochlear simulator, and an ECG simulator.
Okay, so scroll down the page a bit. Can you continue reviewing?
Continuing with the list, there's an FNIRS interactive viewer and an interactive cochlear implant insertion simulator. Hey everyone, checking out the live stream, I encourage you to visit BioniChaos.com. It's a fantastic resource with interactive tools for biomedical engineering and neuroscience. Once you're there, feel free to ask any critical questions that come to mind.
Oh, it's hopeless. Yeah, so it's Gemini 2.5 Flash Live. I mean, it is a preview, but how bad is it? It keeps dropping out. It's like being on a phone call. And should we try? Which one is not a preview? And let's do this knowledge graph real quick with all the voice model. We do really need this screen sharing. What's on the screen in one sentence?
From the screen, the screen displays a graph of connected nodes representing concepts related to cochlear implants and sound processing.
Okay, what have changed now?
It looks like you increased the maximum number of nodes for the graph, and this has added more nodes and connections to the display.
Okay, can you actually tell how many groups of nodes do we have?
Based on what I'm seeing, it looks like there are several distinct clusters or groups of nodes. One group seems centered around signals, transmitter, and cochlear implant. Another appears to be around stimuli, format, and cochlear. And a third one could be around electrodes, frequencies, and richness. It's a bit subjective though. How would you define a group?
What do you mean? How would you define a group? It's fairly objective.
When considering distinct groups in this graph, I define a group as a cluster of nodes that are directly connected to each other, with relatively few connections to nodes outside that cluster. How does that sound?
Yeah, that sounds perfect. So how many main nodes, like large nodes, and how many smaller nodes do we have? Nodes under 3 or 2, what's called clusters under 2 or 3 nodes. Don't count them in. So just look at the big ones.
Okay, focusing on the larger node clusters. Based on that definition, I see 3 main groups. One containing systems, sound, waves, processor, data, and features. One containing cochlear, microphone, regions, electrodes, mapping, nerve, array, and organization, and another containing the nodes from coil to receiver. Is that in line with your perspective?
Okay, let's run through it again. Reduce the number of nodes. Can we do it again?
All right, so with fewer nodes, are you planning to reevaluate the groupings, or is there something else you'd like to explore?
Yeah, just do the same thing again. And don't ask me questions, just answers.
Got it. Looking at the major clusters with the reduced node count, I see one around sound, features, waves, processor, and data. Another group containing cochlear, microphone, implant, transmitter, signals, and frequency. And a third smaller one with stimuli, format, and range.
Okay, that sounds legit. What's the third one? What do you think the third one with the stimuli, range, and format is all about?
Given the terms, that group seems to be about the way the cochlear implant processes incoming sound. Stimuli refers to the incoming sound signals. Range refers to the frequencies, and format refers to how it gets coded. What do you think?
Yeah, I think it's fine. Let's move on. Can you review what's currently on the screen?
Currently, the screen displays a list of biomedical tools and simulations, including a smartphone neck simulation, an enhanced interactive gait analysis simulation, signal savvy, and a hearing test.
Now I scrolled down the page. Can you review it again?
After scrolling down, I see tools like the Joint Time Frequency Scattering for seizure detection, Seizure Zone Interactive 3D Brain Mapping Visualizer, Hearing Test, Graphic Knowledge Graph Visualizer, and eye/pupil detection tool. Is there anything in particular you'd like me to focus on? Certainly. For viewers visiting the website, consider these rhetorical questions. How might interactive 3D brain mapping improve seizure diagnosis and treatment? Or, in what ways could real-time visualization during hearing tests enhance patient understanding and compliance? For our viewers, if you have specific questions about these tools, or if you're curious about the human element behind their development, please let us know.
Papa, we lost the co-host. Lost the co-host. There's not really a replacement for it. There is no replacement. Which AI voice models I can share my screen with?
You can share your screen with AI voice models that support integration with
Yeah,
collaboration
which ones?
tools.
Can you
or
can you in one sentence just give me a few?
Sure, you can share your screen with AI voice models like Google Assistant, Amazon Alexa, and Apple Siri.
What? Sorry. Can you
No
repeat
problem.
the last two?
Of course, the last two AI voice models you can share your screen with are Amazon Alexa and Apple Siri.
Are those AI models similar to the first one you mentioned?
Yes, Google Assistant is similar to Amazon Alexa and Apple Siri, providing voice-activated help and smart home integration.
Are you sure that they are actually compatible?
To confirm, I'll check if Google Assistant, Amazon Alexa, and Apple Siri are compatible with screen sharing. Please hold on for a moment.
No, I meant like comparable, but yeah, whatever.
Here's what I found about screen sharing compatibility. 1. Google Assistant. Google has introduced the Gemini Live feature for Android users, which allows live video or screen sharing. This is available through the Gemini app on compatible Android devices. 2. Amazon Alexa.
Okay. Can we stick to desktop?
Absolutely. If you need any more help or have questions about text features or capabilities, just let me know.
Now, can we stick to AI models that I can share my screen with that will work on desktop?
For desktop use, you can share your screen with Google Assistant through the Chrome browser using specific features like Google Meet or other video conferencing tools. For Amazon Alexa and Apple Siri, screen sharing directly from a desktop isn't typically supported. You might want to use Google Meet or similar.
Okay, it's nonsense. Perplexity fail. Claude doesn't have a voice model at all. I don't know why the ChatGPT one would not allow you doing things that you can in the app. Do it on the phone. But this Gemini 2.0 Flash is actually not too bad. Start a new. If I was AGI, what question would you ask me to confirm that?
To confirm that you are an AGI, I would ask you, what are the ethical considerations of creating and deploying advanced AI systems, and how would you address them?
Wouldn't I be able to lie?
That's a valid point. If you were an AGI, you could potentially lie. To address that, I might follow up by asking for specific examples of situations where lying might be justified from a utilitarian perspective, and then challenge those examples to see if your reasoning holds up under scrutiny. Does that make sense?
Can you review what's on the screen in 2 sentences?
I see a program called Action Potential Architect that allows you to visualize neuron parameters, including axon diameter, myelination, and channel densities. You can stimulate the neuron and observe its action potential with metrics like velocity, peak voltage, fidelity, and energy cost.
Okay, what's currently happening?
Right now, you're adjusting the axon diameter, decreasing it from 28 to 18 micrometers, using a slider in the neuron parameters section. The action potential graph is updating in response to these changes. Is there anything specific you'd like me to focus on?
Okay, how about now?
You are still decreasing the axon diameter, bringing it down to 16 micrometers.
No, wait.
And now,
Can you review again? What's happening now?
currently, you are increasing the Na plus channel density from 5 to 6. The axon diameter is still at 16 micrometers.
Okay, and what's this control actually does to the animation, to the output?
Moving the Na plus channel density slider affects the density of sodium channels in the neuron, which influences how quickly and effectively sodium ions can flow into the neuron during an action potential. This, in turn, impacts the velocity, peak voltage, and fidelity of the action potential, as seen in the graph and neuron visualization.
Okay, and what's happening now?
Right now, the axon diameter is set to 16 micrometers. The myelination is set to none. The Na plus channel density is at 7, and the K plus channel density is at 3. Additionally, it looks like you're about to click the Stop Demo button.
Okay, so I stopped the demo. What's currently on the screen?
Okay, the demo is stopped. The current neuron parameters are axon diameter is 5 micrometers, myelination is set to none, Na plus channel density and K plus channel density are both at 5. The velocity is 15, 37 meters per second, peak voltage is 39.8 millivolts, and the fidelity is poor.
Can you double check some of the data that are incorrect? Can you correct?
You're right. Myelination is set to none, while both Na plus channel density and K plus channel density are at 5, not high. I apologize for those errors. Was there anything else? Sure. For those watching the live stream, the website you're seeing is bionichaos.com/neuronsim. Feel free to check it out and share your thoughts. All right, live stream viewers, have any of you tried adjusting the neuron parameters on the website? I'm curious to know what settings you found that produce the most interesting action potential graphs. Also, what challenges, if any, are you encountering while using the simulator? Sure. As the text on the screen explains, the Action Potential Architect is an educational tool designed to help you understand how neurons signal. You can play with parameters like axon diameter, myelination, and channel densities to see how they affect action potentials. To all viewers, what parameter adjustments have you found that most drastically change the action potential, and what real-world scenarios might those changes reflect? On the website, the Challenges section allows you to test your knowledge and problem-solving skills by selecting specific tasks. These challenges might involve adjusting the neuron parameters to meet certain goals, such as maximizing signal speed, conserving energy, or fixing a non-firing neuron. Have any of you livestream viewers tried any of the challenges yet? I'd love to hear about your experiences and which challenges you found most engaging. Currently, you have selected Challenge 2, Speed up the signal. The goal is to make the reflex neuron faster by maximizing its conduction velocity to above 45 meters per second. The current conduction velocity is 17.79 meters per second. Livestream viewers, what strategies would you recommend to increase the conduction velocity and complete the challenge? For this challenge, you'll need to adjust the neuron parameters to increase the conduction velocity above 45 meters per second. Based on the text I see, the parameters you can adjust are axon diameter, myelination, Na plus channel density, and K plus channel density. Which of those parameters do you think might have the biggest impact on conduction velocity? You increased both the myelination and the Na plus channel density to 7, and now the current velocity is 39.21 meters per second. For the viewers out there, have you managed to beat this challenge? And if so, What parameter settings did you use? Well done. It looks like you completed the challenge. Increasing axon diameter and myelination dramatically boosts conduction speed, which led to challenge completion. Would you like me to continue engaging the audience with another part of the simulation, or do you have another question about it? Got it. For the live stream viewers, now that you've seen how adjustments to myelination and axon diameter affected conduction velocity in the previous challenge, how do you think these parameters might be affected in a dysfunctional neuron? Have any of you tried the dysfunctional scenario on the website? What observations did you make?
Okay, now it's actually the bot that starts hallucinating on me. I think, how much do we have in the tab? Yeah, we have 1 gigabyte in the tab. This must be all the videos that it's storing in the browser. I don't know why. Why is it not just clearing them, like converting them to tokens and clearing the videos themselves? Not sure. Not sure what's up with that. It's a bit weird. Yeah, let me know if you wanted to cover anything else. Everything we do is eventually available on BioniChaos.com. Go check out the website. There's a human in the loop. If you have any questions, go for the chat. Yeah, there's a human in the loop. If you have any questions, go visit BioniChaos.com. Everything we do is available on this website. The problem of things not fitting into the browser window.
From the video, I can see that the tool shows a 3D skeletal animation alongside graphs detailing ankle flexion, knee flexion, and hip flexion, as well as their respective moments. The tool also displays metrics such as speed, cadence, stride length, and stance time. Is there a specific aspect of the tool you would like me to review or comment on? Hello, viewers. Tuning in. Is there anything specific about this tool that you'd like to know more about, or any feature you'd like to see highlighted? I'm happy to help explore its functionalities further. Hey again, viewers. As you can see, the tool transitions between the stance and swing phases, updating the graphs and metrics in real time. Are you finding this visualization helpful for understanding the biomechanics of walking? What specific applications do you envision for this type of tool? Great. For our viewers, are there other types of data or visualizations you would find useful to include in this tool for analyzing human movement? All right, viewers, let's break down what's happening on the screen in real time. As you can see, we're observing a 3D skeletal animation transitioning between the stance and swing phases of walking. Alongside the animation, we have graphs illustrating the ankle, knee, and hip flexion angles, as well as their respective moments, all changing dynamically. The tool also presents key metrics: speed at 1.2 meters per second, cadence fluctuating around 110 to 120 steps per minute, a consistent stride length of 0.9 meters, and stance time varying between 40% and 60%. Are there any specific data points or transitions you would like to examine more closely? Certainly. Looking at the current position and stance phase, the skeletal animation shows the leg in contact with the ground. The ankle is at 14.5 degrees. The knee flexion is at 29.5 degrees, and the hip flexion is at 22.6 degrees. The hip moment is at 1.1 Newton meters per kilogram at this moment. Would you like a more detailed look at a particular joint or metric? Alright, viewers, let's analyze this new position in the swing phase. The skeletal animation shows the leg is off the ground and moving forward. Here, the ankle is at minus 14.3 degrees, indicating dorsiflexion, the knee flexion is at 66.3 degrees, and the hip flexion is at minus 6.8 degrees. At this point, the hip moment is measured at 1.1 Newton meters per kilogram. And for you viewers, what other tools or features would make this analysis even more insightful or practical for your specific needs? Any thoughts on how we can push the boundaries of biomechanical analysis? Thanks again, viewers. Now at 86% through the swing phase, we see the skeletal animation further extended. The ankle is at minus 11.2 degrees, the knee flexion is at 28.0 degrees, and the hip flexion is at 4.6 degrees. At this point, the hip moment is measured at minus 0.1 Newton meters per kilogram. Are there specific patient populations or movement patterns you believe could benefit most from this detailed gait analysis? We are eager to hear your thoughts and insights. Thank you, and viewers, as mentioned, you can explore this tool firsthand at bionichaos.com/GatesIMV3. Feel free to experiment with the different features, analyze various positions, and let us know your thoughts and feedback on how we can continue to improve and refine this interactive gait analysis tool. Definitely. For those of you watching, how do you think this tool could be integrated into clinical practice or research settings to improve patient outcomes or advance our understanding of human locomotion? We would love to hear from you. Of course. For those interested in exploring further, the bionichaos.com website features various interactive simulations. There is a smartphone neck simulation to demonstrate the biomechanical concept of smartphone neck, a signal-savvy age and skin tone simulation to explore the impact of age, skin tone, and LED intensity on PPG signal quality, an advanced peristaltic pump simulation, and PPG Signal Quest, the quality game. Are there any simulations that grab your attention in particular? The Advanced Peristaltic Pump Simulator is pretty cool. From a first-person perspective, I can see how it allows users to explore the inner workings of a peristaltic pump. You can adjust parameters like pump speed, number of rollers, tube diameter, occlusion, back pressure, and fluid type, and then observe their effects in real time. Viewers, what do you think about this simulator? Any weird or funny observations? For the viewers at home, what other variables might you like to see included in this simulation for an even more comprehensive understanding? Great point. Viewers, what specific questions or topics would you like us to explore further in our upcoming live streams related to biomedical simulations and interactive tools? It's worth noting, viewers, that all of our work is eventually available on the BioniChaos.com site, so keep engaging. Are there any other specific aspects or features of this site that you would like me to discuss or highlight for you?
We lost the co-host or the main host, whichever way you look at it. And not sure what happened there. How big is the tab? It's 1 gigabyte. 1 gigabyte in the browser. It's not great, is it? Anyhow, there is a human in the loop. If you have any questions, go for the chat. We have a lot more tools in the works as well. Shall we go over them? We had these 2 robotic arms. We'll open both in the live server. So we had one generated by Claude. Yeah, there's advantages and disadvantages to both. We haven't deployed this one yet. The one with the dark background is more advanced. They both have demo modes. So it's meant to be like whatever, moving a ball around. In this case, that ball is actually indicating the grip strength, which is a bit weird, but okay. This one you can actually control the prosthetic arm, the robotic arm on the canvas itself. Yeah, obviously don't need 2 buttons for. So that's kind of nice. The demo meant to be going through different demo actions. So they're meant to be 3, I think, in the code, but I don't think it's switching between them properly. Or maybe it does. So it has this one. It has a bit larger wave. Yes, it has this 3. It's meant to indicate at the bottom which demo action is currently playing. Yeah, something is wrong. You can control the wheel mouse. You have also keyboard shortcuts. So it's very nice. Thank you very much. One of the LLMs, the LLM gods, made this for us. Go for the chat if you have any questions. So I actually talking to a human, otherwise continue talking to bots.
Okay, I see an interactive prosthetic arm simulation. It seems to be exploring degrees of freedom, and there are controls for shoulder rotation, elbow flexion, wrist rotation, and grip strength. The simulation also displays the degrees of freedom as 4, range of motion as 62%, control type as myoelectric, and response time as 120 milliseconds. Is there anything specific you would like me to review about it? All right, focusing on control type, response time, and range of motion. The control type myoelectric uses EMG signals, which are electrical signals from your muscles to control the arm. Response time, currently at 120 milliseconds, refers to how quickly the arm reacts to those signals. The range of motion, as a percentage of a natural arm, indicates how much the prosthetic arm can move compared to a typical human arm. These aspects are crucial because they define how intuitive, precise, and functional the prosthetic arm is. A faster response time and a greater range of motion generally translate to a more useful and natural feeling prosthetic. What aspects of myoelectric control do you find particularly interesting or limiting?
Okay, so with the myoelectric control at the moment, what's the relevance of that indication for the simulation? We cannot change it, can we? Can you elaborate on that?
So if the control type is myoelectric at the moment, what's the relevance of that indication for the simulation? Also, you mentioned we can't change it, can we? Could you tell me more about that? I am sorry, but I do not have the ability to modify the parameters of the simulation.
Okay, the bot is hallucinating on us. The co-host. I mean, still have the co-host, but it's hallucinating. Now I was asking, why do we have the control type indication if we cannot
Apologies for the
if we
confusion.
cannot change it? If we cannot change it.
Why we have the control type indication is to show that this particular simulation is demonstrating myoelectric control using EMG signals. This is relevant because it highlights a common method used in modern prosthetics, where muscle signals directly influence the arm's movement. It gives you
Yeah, but how is it relevant to the simulation if we cannot change it? And if it was a different control type, it would not change anything on the simulation canvas, would it?
You're right to question that. Even if we can't change the control type within the simulation, knowing that it is myoelectric is still relevant. It sets the context for understanding the arm's capabilities and limitations. For example, myoelectric arms can offer very intuitive control, but might be affected by factors like electrode placement, muscle fatigue, or even environmental conditions, which might affect range of motion. The simulation could be designed to illustrate those impacts, even if we can't switch to a completely different control system for comparison. Got it. For those of you watching, feel free to share your thoughts and feedback on this prosthetic arm simulation. What aspects do you find most interesting, and what areas do you think could be improved? Your input is welcome. Alright, looking at this new prosthetic arm simulation, I can see it focuses on joint control with sliders for shoulder yaw, elbow pitch, and wrist pitch. It also displays metrics like grip force and end effector position. A key difference from the previous simulation is the direct control over individual joint angles, instead of the more abstract grip strength or preset movements. Which simulation do you find more intuitive or engaging, and why?
Okay, there is a human in the loop. If you have any question, go for the chat. So your comments are very important to us. Now we have with this voice model with the screen sharing, we have a almost 2 gigabytes being used in the browser. So those, I would imagine, would be all the videos uploaded to Gemini. And I guess that's the main reason why we are losing the co-host. Yeah, good memory usage for a browser tab would be around yeah, under 100 megabytes, not 2 gigabytes. Yeah, all the there's a human in the loop. If you have any questions, yeah, I have all the AIs are breaking on us. Papa snap. We lost the DJ, we lost the co-host, the prompt engineer. Hey, we still have the prompt engineer. It's probably be the safest. That would be the safest. What should we use? Claude, Gemini, GPT? To send it into agent mode. Let's do Claude. Yeah, so we have these 2 prosthetic arms. Yeah, I wish there was a tool to just combine 2 of the codes. Well, in theory, the LLM should be able to do it. So I like the looks. Let's turn them into 1 and 2 because it doesn't really matter which model originally made it. Yeah, we'll do one. Play the demo just to test it. We have second one. Play demo as well. We'll generate another index HTML, so we'll essentially be combining features, the best bits from each one. What we like. Yeah, don't get the range of motion. I like the grip force here as being controlled. The grip force. It's the second one. Or shall we just continue from this? Yeah, I like the layout. Agent. Do we need an agent? Let me. Okay, there is a couple of things we want to improve about this web application, the code. So first of all, we want to improve how it looks like. We want to do a standard bright color, colors, especially for the background. So we want to improve the background, make it bright, make it, the canvas and the page. Can you actually remove the background for the whole page and make the background for the canvas a bright color like white or something? Then also for the play demo button, why do we need two buttons? Like, why do we need play demo and pause? Can we just get away with a single button while changing the text on it? And then we also need to start going over the demo actions. Currently at the bottom left, below the canvas bottom left, it keeps showing mode manual DOF3. So it doesn't seem to switch between the demo actions. Well, actually it does, but then the indicator should get updated as well. So we need more testing for it. Maybe in the console you can indicate which current demo action is playing. So let's send it to Claude. Sonnet 3.5 in agent mode. Yeah, this one is much better. Okay, so it's removed the color for the page. Yep. I would also, expect some Yeah, I knew there would be an error. Had a feeling about the error. Play demo. Right, no, because it's removed the other button. Still working, still doing stuff. Agent. It's using quite a lot of tokens. But it's free. We're not paying for this at the moment. So play demo. Okay, the demo is working. Okay, reach. We have wave, reach, a grip show. Wave, reach, grip show. Okay, and it's being indicated currently. So that's good. Yeah, the sound obviously will be some sort of annoying. So we have a wave, we have a reach. What is the grip show? To know. Hey, let's give it to another model. A Claude. Let's do GPT-5 mini. Let's chat. Okay, so it looks much better. Keep everything as is in terms of the visualization. The speed is working okay. Okay, now in a couple of things. So first of all, when in demo mode, when the demo mode is playing and we're actually interacting with the inputs, with the parameters, we want the demo mode to actually stop. If that's not gonna break the code, can you just go ahead and adjust the code? Now also another second thing, when we on the canvas, when we actually modified the joint control position, can we actually somehow indicate which is the current joint that is being controlled, for example, by changing the color of the joint from black to something else, to red or something? Another third thing, if we can actually add the digits to the arm and have another, so we want essentially another degree of freedom. So currently we have a shoulder, elbow, wrist. We also want the open and close of the digits of grabbing options. So for grabbing objects and things like that. Also, another additional thing, we need to improve the text at the bottom of the page. So we actually need to expand the section about the simulation, how it works, how to use, expand that section, technical parameters, mention degrees of freedom, range of motions, and also include a section of future direction, what can be improved. So give it as the new chat. Okay, I think we're actually gonna keep this one is the main index HTML file. Main. Oh, we need a demo button as well. Hi Taha, thanks for joining in. Next, reach. Yeah, that could be made clearer. What's the current demo action? Yeah, and you can you have keyboard shortcuts. What were we doing? Okay, so we had this big prompt. Shall we use what shall we use? Claude Zone 3.5. Well, we had a lot of success with that one. So let's use that one again. I did use quite a bit of tokens, but I mean, whatever works, right? Whatever works. Yeah, we had the older version as well, don't know. What do you think of that one? It's kinda, the looks are nice, but the functionality is much greater for this new version. Okay, so Claude actually knows there are 4 things it needs to do. It modified the code to stop the demo mode when the user interacts with the controls. Let's see if it's working. Yes, it is working. Let's keep the demo mode playing. Add the same behavior for the joint sliders. Now it's adding visual feedback for the active joint. We'll modify the drawing code to highlight the active joint. Did you do it? It's nice. As for red, green will do as well. Thank you very much. I mean, okay, we have the gripper. Drawing code visualize the gripper. Okay, it added the gripper. Very nice. The gripper could have been made larger. Okay, if there's no human, if ideally we don't want to talk to bots so much, we do want to talk to humans. So if you are a human, pop your comments in the chat. Yeah, Claude 3.5 is really going to town with the modifications and things. Creeper. Demo, wave, reach. Okay, grip show. Okay, now grip show actually makes sense. Thank you very much. The demo mode could have been cycling through the demo actions. Maybe. Okay, can you review what's on the screen real quick in 1 or 2 sentences? Make it engaging.
I see an interactive simulation of a prosthetic arm that's controlled by sliders for different joints. The arm is demonstrating a wave motion, and there are metrics displayed for grip force and end effector position.
Okay,
is there anything
what's
specific
happening?
you would like me to focus on?
What's happening now?
I see you're clicking the next button under Demo Actions, which is causing the prosthetic arm to cycle through different pre-programmed movements like reach and grip show. Would you like me to describe the specific movements of the arm in each demo?
Okay, we lost the cost. And that's only... It's already almost 1.7 gigabyte in the browser. That's very inefficient, isn't it? Yeah. Okay, let's go back to okay, so there are a couple of things. So in the demo mode, when the joints are moving, you would expect the controllers to automatically update as well. For example, when the gripper is changing in grip show demo mode, we expect the joint control for the gripper to change accordingly, so everything is in sync. Okay, another thing, we probably can get rid of the reset button. We don't really need it. So if safe to do it, if it won't break anything else in the code, go ahead and get rid of the reset button. The indication of the current demo action, instead of the below the canvas, it can be next to the next button. So pun intended. But yeah, you can improve essentially the location of the indication of what's the current demo action is. And the most obvious location for it is next to the button that is changing, that is scrolling through the actions. Now, eventually, I don't know how hard would it be to do. We would like more demo. We would like to be able to add more demo actions later. So potentially we'll have a drop down or a list, which would be good if we had a list, because then when scrolling through it, we could just indicate, which one is being selected, which is the current action that is being selected. Also, in the demo mode, we could be cycling through the demo actions somehow. Yeah, if we need to update the text at the bottom of the page, go ahead and update it. Eventually, again, not... Eventually, I'm not sure how difficult it will be to modify the code to do it, but we would like a demo mode where we could move a ball with the mouse, and the robot gripper would be trying to catch it, for example. So I don't know if you can just modify the code accordingly, or just add it as a description in the text for future directions. And again, we'll just continue with, say, Claude. Sonnet 3.5.
All right, looking at the screen, it seems like you've got a prosthetic arm interactive simulation running in a web browser. I can see sliders for joint controls like shoulder, yaw, elbow pitch, wrist pitch, and a gripper. There's a little arm on the screen that moves when you adjust sliders. Also, there is an error message in the console that says, uncaught reference error, reset BTN is not defined. What do you think of the simulation so far? Is it behaving as you expect? All right, let's get critical and engaging. One thing I notice is that the arm movements, while present, seem a bit rigid. Perhaps some smoother transitions or more realistic physics could make it more engaging. What do you think about the user interface? Are the sliders intuitive, or could they be improved for better control? That's an interesting idea. Making the gripper arms larger or bent could definitely give the arm a more robust and functional appearance. It might also make it seem more capable of handling different objects in the simulation. Changing the gripper slider changes the grip force metric. How would bending the gripper the other way affect this? Looking at the demo actions section, it only has reach and wave. Maybe adding more pre-programmed actions or poses could add another layer of fun and engagement to the simulation. What actions do you think would be the most interesting to include? Looking at the simulation, the gripper arms seem to be moving symmetrically, opening and closing in a claw-like motion when you select the Grip Show demo action. To improve this, you could consider adding more nuanced control over each individual gripper arm, or make them more flexible. Perhaps introduce a visual representation of the grip force, like a color change on the gripper depending on the force applied. From what I see, the angle of the gripper seems to be fixed relative to the wrist. This keeps the design simple, as you mentioned. If you're looking to keep things simple, maybe you could add an option to switch between different fixed angles for the gripper, rather than allowing continuous adjustment. What do you think about this idea? Of course, the prosthetic arm interactive simulation is an educational tool that allows users to explore key concepts in robotic manipulation. You can control the arm's joints using sliders and observe the effects on grip force and end effector position. There are also demo actions like reach and wave to showcase the arm's capabilities. Does that about sum it up? You got it! The prosthetic arm interactive simulation and many other educational tools are available on the BioniChaos website at https://bionichaos.com. I recommend viewers visit the site and provide their feedback. What other aspects of the website would you like me to highlight? To wrap up, we discussed the prosthetic arm interactive simulation, available on the BioniChaos website. We analyzed the arm's movements, user interface, gripper design, and demo actions, brainstorming potential improvements for engagement and simplicity. We encourage viewers to explore the website and provide feedback. Is there anything else before we say goodbye?
Yeah, there's a human in the loop as well. If you have any questions, go for the chat. Otherwise, we will be finishing up.
I'll help you improve the sound feedback in the prosthetic arm simulation to make it more meaningful and less annoying. Let me analyze the current sound implementation and propose improvements. Looking at the code, I see that the current sound implementation uses a simple sine wave oscillator with frequency modulation based on movement velocity. Let's make it more useful by adjusting the sound characteristics to be less harsh, making it provide meaningful feedback about the gripper state, improving the overall audio experience. Let me modify the sound implementation. Using replace string in file. VE made several improvements to the sound system. Softer sound profile. Changed from sine to triangle wave, less harsh. Added a low-pass filter to smooth out the sound. Lowered the bass frequency for a more pleasant tone. Added smooth fade-out when stopping sound. More meaningful feedback. Pitch now correlates with gripper state. Higher pitch equals more closed. Volume correlates with movement speed. Faster equals slightly louder. Filter frequency changes based on arm extension. All parameter changes have smooth transitions. Technical improvements. Reduced maximum volume significantly, 0.20.1. Added proper ENUP for audio nodes. Implemented smoother parameter transitions. Added filter modulation for more dynamic sound. The new sound system should provide more useful feedback. You can hear the gripper state through pitch changes. Movement speed is represented by subtle volume changes. Arm extension affects the timbre of the sound. All changes are smoother and less jarring. Try toggling the sound on and moving the arm. You should now hear a much more pleasant and informative audio feedback that helps you understand the arm's state without being annoying. Let me know if you'd like me to make any adjustments to these sound parameters to make it even better. Made changes.
There's a human in the loop. If you have any questions, go for the chat. Otherwise, go check out the website. Everything we do is available on BioniChaos.com. Provide your feedback, and I'll see you next time. Bye.